Hi, my name is Connor Carreras, and I'm a solutions engineer at Firebolt. We're going to be talking about primary indexes in Firebolt, how they work, and how to set them up. So primary indexes are an absolutely fundamental part of how Firebolt is able to give you low latency, high concurrency queries. You absolutely should add primary indexes to every single table that you have in Firebolt. So you're going to define your primary indexes as part of a create table statement. And then every time you ingest data or modify the data inside the table, Firebolt is going to keep your primary indexes updated and in sync. So how do indexes work? Let's start at a super high level. So at the most basic level, primary indexes organize data stored in Firebolt based on column values. They're going to sort and group records. By doing this, you're going to ensure that whenever you send in a query that involves a column that's in the index, that query is going to target the most relevant data, reduce the amount of data scanned. So instead of looking at the full table, you're looking at exactly that chunk of data that represents what you need in your query. And it's going to make queries run super fast because the less data that you end up processing, the faster your query runs. It's just physics. So a good analogy for this is like finding a book in the library. So if you think of something like partitioning, which is a pretty common data chunking or data organization strategy in a database, partitioning is kind of like alphabetization. So you know, okay, the book is by an author C. I'm going to run through and try to find all of the authors with C to find my book. Indexing in Firebolt is like using the Dewey Decimal System. So you're grouping the data and you're able to identify, okay, I know that it's a C, but it's a technology author and it's about databases and specifically about data warehousing. So we're going to go exactly to this shelf and voila, we're looking at maybe 5 books instead of 500. So it's important to remember when you're thinking of Firebolt primary indexes that they are sparse, columnar, and operate over groups of data. So if you're used to thinking about a traditional database system that's using primary keys are great for efficient retrieval of individual rows. They're not good for operating across groups of records, which is really what Firebolt's indexes are designed for. Let's drill down one level deeper. When you create a table in Firebolt with primary indexes, the underlying FFF files are divided into something called tablets, and those tablets are sorted by primary index. Each tablet is a self-contained chunk of data, approximately 3 gigabytes in size. Within each tablet, you then have what we call intra-tablet ranges. I'm just going to call those ranges in this video so that I don't keep saying intra-tablet, but those ranges are approximately 8,000 rows. And again, the tablets and the intra-tablet ranges are determined by what you've chosen as your primary index. So let's imagine we've got a table that is indexed on country and date. So here is our table. So here's our table. This is a very small table. So we've got 4 records. 3 of them are from Great Britain and have varying dates between January and February. 1 record's from USA, date of Jan 1. So when this gets ingested, we would imagine that this would come into a tablet. And let's just say the first range that we're working with is going to hold Great Britain. And the starting index of that range is going to be Jan 1. And that's going to go all the way through Great Britain, Feb 2 or Feb 1. And then our next range is going to be USA, Jan 1. So Firebolt is going to keep track of what these ranges are. So this is row 1, we'll imagine it's 8K, and then this is range 2, this is row 1. And attached to this tablet, we're going to attach an index. The index is going to just store the first value in each range and where it lives. So we're going to say range 1 is GBR, Jan 1, and that is at place 1. And then 1-1. So range 1, place 1. And then we're going to say that GBR Feb 1 is at space 1, range 8K. And then USA, Jan 1, is at range 2, row 1. So this piece right here, this index, is what's going to be critical when the queries come through. So essentially, let's imagine we have a query that says, hey, give me all of the data from the USA from January 1st through January 30th. Firebolt is going to first read from our index right here. And it's going to immediately identify, okay, let's see, we've got USA Jan 1 in our index. That data lives at range 2, spot 1. So let's go and grab the data from the tablet, bring it into the query, and return that to the user. So this means that when you're configuring primary indexes, you really want to make sure that the indexes are closely aligned to the query patterns that you want to filter on. So in this case, we've set up country and date because these are the really common ways that people are interacting with my data set. And so by having this index, we're able to quickly say, here's the data you need, here's the exact records, here's a very small representation of those records. Let's return it to the user. Let's take a look at how primary indexes impact querying. So what I've got here is a pretty standard analytical query. So we're going to sum up ad revenue from our table and filter this on a couple of different dimensions, visit date and country code. I've set up 3 different tables. So the first table, user visits no indexes, is exactly like it sounds. You can see my create table statement here. This has no primary indexes. There is a second table that has some but not all of the filters in this query as the indexes. That's this table called user visits. So you can see again, if I look at the create table statement, we have visit date as part of the primary index, but we don't have country code. And then finally, our third table, user visits with indexes, has country code and visit date both in the primary index. So what you would expect before we run these queries is that user visits with no indexes is going to be the slowest of the 3 queries and scan the most data, followed by user visits with one of our 2 columns in the index. And then the absolute fastest that scans the smallest amount of data is going to be the table that has both visit date and country code in the primary index. So let's go ahead and run this query. I'm going to run all 3 at once so that we can very quickly compare. So these ran sequentially. So query 1 is the one at the top. So this was user visits no indexes. What we can see if we look at it is that query 1 ran in 1.53 seconds and it scanned 21 gigabytes. So a decent chunk of data. Query 2, so this is the one that had visit date in the primary index but not country code, ran in less than a second, specifically 11 milliseconds. It scanned way less data, only 745 megabytes. And then our last query, the one that was very well tuned for the indexes on the table. So we were filtering on country code, which was in the index, and visit date, which was also in the index. That ran in 0.01 second and scanned only 16 megabytes. So you can see really clearly the impact of good primary indexes on your query speeds. You could imagine that, if you had a lot of queries like this last one that had very strong matches between the filter conditions and the primary index, you could stack a lot of these queries on a single engine, have them all run very quickly, and have a high query throughput. So this is exactly how you get high concurrency, low latency with Firebolt. You've just seen how primary index selection can have a huge impact on how quickly a query runs and how much data it scans. So the question that might be going through your mind is, well, how do I go about choosing the best primary indexes so that I get that 0.01 second query and not the 1 second query? So there's a few best practices that you should follow when defining primary indexes on your tables. The first is that you want to focus on highly selective predicats. So what this means is that you want to include columns in your where clauses, your predicates, that are going to filter away a lot of data. So in the example that I demoed, you saw that date was one of the primary index columns. Date is usually a great candidate for a primary index because it's always going to filter a lot of data. In a given year, there's only 1 out of 365 possible date ranges that you can filter on. You're going to toss all the others away. The second best practice is the ordering of the columns in the primary index does have an impact on the amount of data that's going to be scanned. In specific, you want to go from low cardinality to high cardinality. What this means in particular is that the first column in your primary index ideally should be a column that doesn't have a lot of unique values. As you go through the columns that you're including in your index, you're increasingly going to include columns that have more and more unique values. The reason you're going to do this is because Firebolt, when it's doing its data pruning, it really likes to get long runs of ordered data. So if it can read through, 20, 30, 40, 1,000 records that are in order, it's going to prune really effectively. The third best practice is that you want to include join keys in your primary index. So a lot of times when you're working with data and you're building these queries, you're going to be joining fact tables, dimension tables. If the join keys are part of the index, join keys are always acting as kind of an inherent way to filter the data. If you find a match in the dimension table that you're bringing in, that's going to keep the record. If there's no match, that's going to fall out. So join keys operate as filters and as such are a good input for pruning. And then finally, include as many columns as necessary. Include many columns is what I'm going to write. So you're not limited in Firebolt to only specifying 1 or 2 primary index columns. You can have as many columns in the primary index as you need to support your common query patterns. And so if you anticipate that maybe there's 5 or 10 columns that are commonly going to be used by your end users as part of their queries, put those columns into the primary index. There's a little bit of a caveat here, which is as you include more columns into the primary index, that may impact ingestion time slightly. But generally, the trade-off between having more columns and better matches to your query patterns versus the amount of time or small additional time that ingestion is going to take is worth adding the columns to your index. Hopefully you are now an expert in primary indexes in Firebolt and have a really good understanding of why adding primary indexes is critical for getting the fastest queries from Firebolt. We do have another type of index called aggregating indexes that can also be an even further accelerator for query performance. You can learn more about aggregating indexes in the following video. Thanks for watching.